If you get 99% in school, you are genius. Your parents are proud you get an A+. plus. But in the world of industrial engineering, 99% is complete disaster. How? Let us look into it. If the world operates at exactly 99% accuracy, here is what happens today. Over 100 aeroplanes would crash upon landing. Your pharmacy would give out 2 lakh wrong prescriptions, and the bank would lose 20,000 wired money transfer every single day. So, how do we get better than 99%? Today, I'm going to explain the concept of Six Sigma and process capability and show you the hidden math behind it. The math that keeps modern world from collapsing. Let me ask you a question. Would you rather be accurate or precise? Most people think they are the same thing. So, let us see this. Imagine a sniper. He shoots many times and the shots are all around the target. So, his average is at the center. He is accurate, but he missed many shots. Now, imagine he shoots many times and all bullet hit exactly the same spot, but they hit 3 to 10 feet away from the target. He is precise, but not accurate. In engineering, you need both. The ultimate enemy of both is a variation. Think about the last time you ordered a pizza, the app says it takes an average of 30 minutes to deliver a pizza. Are you happy? Not necessarily. If it arrives in 15 minutes one day and 45 minutes in next day, the average is still 30, but your experience is terrible. You never know when to set a table. In a manufacturing, this is called variation. Customers don't feel the average, they feel the variation. If a car part is 1 millimeter too big on Monday and 1 millimeter too small on Tuesday, the engine will explode. So, how do we measure this chaos? Imagine you are trying to park a massive SUV inside a tiny home garage. This brings us to the most important rule in factories: process capabilities. The walls of your garage are the customer limits. Your car is the manufacturing process. If your car is exactly as wide as your garage door, you have to drive it perfectly straight every single time or you crash. This is a low process capability. But what if I told you that you have to drive a motorcycle into a massive garage? You can still get inside without touching the wall. This is called high process capability. So now we know we want the motorcycle, not an SUV. But what does the word sigma actually mean? The sigma word is just the Greek letter engineers used for a standard deviation, a measurement of how fat or skinny your data is. If you measure 1,000 parts coming off an assembly line, they will naturally form a bell curve. The middle is your average. One sigma is the step away from an average. If your bell curve is fat, your parts are wild and unpredictable. If your bell curve is super skinny, your parts are virtually identical. So, why do we aim for 6 sigma? Why not 1, 2, 3 sigma? Let us go back to our parking garage example to understand this. If you operate at 3 sigma, your process fits inside the garage limit, mostly. But out of every 1 million parts you make, 66,800 of them will crash into the wall. This is a massive waste. But if you squeeze the bell curve so skinny that you can fit 6 standard deviations between the average and garage wall, you hit the magic number. At 6 sigma, you only produce 3.4 defects per million opportunities. 3.4. You are mathematically bordering to an absolute perfection. In short, we are setting limits far away from the mean. But let me show you what this actually look in an industry. Watch this. Both of these machines take an average of 10 seconds to produce a part. But machine A has a huge variation, sometimes 5 seconds, sometimes 15 seconds. Machine B always exactly 9.9 to 10.1 seconds. Look at the queues building up behind the machine A. The variation causes traffic jams, bottlenecks, eventually factory shutdowns. The average was a lie. Simulation proves that variation is a real killer. Six Sigma is not about being perfect once. It's about being relentlessly consistent a million times in a row. It's about shrinking the car so small that it's mathematically impossible to hit the garage walls. Now we know how to make the perfect parts. But what happens if you make perfect parts but completely run out of raw material to build them? In the next video, we are going to dive into dangerous world of just-in-time manufacturing and why having zero inventory is either absolute genius or corporate suicide. Make sure to subscribe, hit the bell icon, and I'll see you in the next one. This is Leansimcorp. If you want me to explain some different topics, write in the comment section below.